Okay, good afternoon, everyone. Thanks for coming to our little chat about solar. My name is Todd Jefferson. I am a senior manager and former business project leader for the Alfresco project that we've done in Michelin, North America. I'll give you just a little bit of insight about, who we are. First of all, I've introduced myself. I have with me Colin Stevenson from Armedia and Corentin Roux from Alfresco, two of the most important guys in the project for sure. They're going to talk to you and spend most of the time with the technical details around solar, but I thought I'd start off by just setting the framework a little bit about the project and what we did. So a brief background, and then we'll get into the more technical stuff. Just from a history standpoint, to give you a little bit of context, Michelin's about a $26 billion company. North America, that's about a third of that. And we have about 25,000 employees in the North American landscape, 19 manufacturing facilities, and a bunch of documents. Okay. You know, one of the most important things with any Alfresco, with any project, I think, is to educate the team. So, you know, one of the things I wanted to point out is if you're involved in a team, make sure that team is educated on the product, whatever that product is. I think it was part and parcel to the success, some of the success that we've had with the project. As an early adopter, I, took it upon myself actually to go get Alfresco, install it on my laptop actually, and read the documentation and learn how to use it. And then I was instrumental in getting a lot of our other team members up to speed on the functionality and capabilities of Alfresco. And then, we actually used agile project development, but then we built out the infrastructure and migrated for this project a legacy based document management system based on DominoDoc. Some of you may know about that, Lotus architecture. And that's the experience that we're going to share most about with you today, the challenges and the things that we've done to help us along the way. Just to give you an idea of the landscape, how many solutions do you use to store your files and information today? I'd say probably too many. This is kind of our landscape, right? So the challenge was to try and reduce the number of repositories and to get to one. We're on our way to doing that. We had a major, like I said, legacy migration of one of our main document management systems in North America, and actually just through grassroots movements now and people liking to use Alfresco, we've actually starting to see attrition in some of the other things without actually doing a formal migration. So that's a good thing too. That's about all I think I had to kind of set the stage for these guys. So maybe if you, okay, one other thing, and I've already said it, understand the capabilities, install it, get to know it, how it works. Demonstrate. One of the things that I did in the business was take it on the road and kind of demonstrate Alfresco and what its capabilities were to build a grassroots movement. I don't know if any of you are in that particular role, but if you are, I think it's it's a very good way to get support, and because when people start telling their manager, hey, we like that better than what we have, and it will improve productivity, it goes a long way to helping you gain support for funding the project if the people out in the field say this is a real productivity opportunity. So, and then educate. And I talked a little bit about learning the product and then teaching the team about the product and what all the functionalities were. Starting with some of the most important ones first, and then obviously getting down into the more detail later. Now, I'll turn it over to Colin Stevenson. All right, he'll take you through the next phase. Thanks.
Yeah, so we want to share a little bit of information on how many people have been using our system, how the growth has happened, and to really encourage monitoring your environment, because if you really don't know what's happening, then you really don't know what you need to tune. If you don't understand your users, then you're going to face more challenges than what we did. So over the course of the last 12 months, we've really gone from 10, 15 users up to over 800 users, and that's concurrent users, not just people in the system. We got about 15,000 registered users, and on a daily basis, we're going to see 700 plus in the system at any given time. So we are really abusing Alfresco quite well. We've also seen document growth, and one thing about monitoring, as you can see, we initially were monitoring the wrong thing, so we had a very steep growth pattern in October till we realized that was our versions. So then we decided, okay, we better monitor the real content. So it's not a huge repository. We're about 3.5 million documents now. Versions are about 9 million. We've maybe got about 700,000 in the trash can, but it's growing. We've got the grassroots adoption and things are starting to move. So monitoring analysis, make sure you do it. So first question, what are you monitoring, and are you monitoring? Are you paying attention to what you're actually monitoring? A lot of people put monitors in place, you get an email, you react to it. Not many people actually pay attention to what those values are giving. And that's one of the things we've been doing. We've been looking at the number of users, the regular users coming into the system, what they're doing, and we're building up a lot of statistics over the last 12 months. So now we can start making educated decisions on where we need to be for the next 12 months based upon real facts. We'll give a quick plug. There's a session tomorrow, tomorrow morning. Miguel, go and learn about a little more about monitoring your Alfresco installation, because it's going to add value to what we're doing here as well. So some of the other things we monitored, if you turn on debug for solar, you can start finding out great information on what the queries are, how long the queries take to run, and how many results you're getting back in those queries. So we turned this on for a period of time, and actually I got spreadsheets I can share if you ever want to try this yourself. And we're starting to see some interesting curves. We have actually 3 nodes in our cluster, but this is just monitoring 2 of them. And now you can start to see peaks before lunch and after lunch. So you're starting to see, okay, that's kind of familiar trends. So it's kind of good. Then we thought, okay, well, let's take a look at some of the results we're actually getting on an hourly basis. Yeah, it starts to skew a little. One of the servers seems to do a lot of work in the morning time and then just before lunch, whereas the other one kind of follows the regular patterns. But, results per hour, we're starting to see quite a lot of queries going on. So what are our users actually doing? It's kind of fascinating now. We're getting over 20 million results going on here. This one is basically a lie detector, which we threw up there. I'm going to try and sell this as art because it looks pretty cool. So, the problem with data is you start to get a bit carried away and you think, what else can we actually derive for this? So this is really queries returned per minute, per hour in a day. So just reading that, you're not making much sense of it, but you can start to see solar is really working very hard. And that's just one node. And we've got 3 nodes. And if that's the kind of work that they're doing, you got to really pay attention to the heart of your system as to what's going on. So, life of solar. We have out-of-the-box installation. You got an Alfresco server, we got a solar server, we've got SAN storage. Try and get the best storage possible for your indexes and make sure it's located as close to solar as possible. You'll hear stories around people putting it on slow storage, wondering why there's problems with searches going on. Make sure you get as fast a storage as possible. Some of the default configurations, which are in the slides, setting up, pointing toward in your Alfresco global properties, where the subsystem you want to use, where the key store is, and what your SSL port. And then likewise, on the solar side, you got some information in the solar core properties. We enable tracking. You tell where your host is, the port, the base URL, and if we're going over HTTPS or not. So this is what we started with. Then as we started to grow up, we started looking at, well, not many people are aware, but out of the box, we track 2 cores. So you can actually separate the cores if you feel that you need more resources on your workspace versus your archive. You can actually run those on 2 different servers if you would like. So we got some sample configuration here. Just you may need to do this. One of our things that we need to do at some point is index the version store. So the version store has 9 million documents. We're probably going to have a little bit of work to do in Solr, so it may make sense to separate out the cores. If you want some information on how to configure these, well, we got some details in here for you. You're going to have to set up a new HTTP factory for where this new core is actually going to reside. So you're actually going to have to set up your global properties, define some new properties. In this case, we said the solr.host.workspace, mimicking the out-of-box properties. So you get those set up like anything else. Then you actually have to update the store mappings and start saying, okay, what properties are we using, what factories are we using, and where are they actually pointing to? So it starts to get a little bit more involved. Next, you need to think about, well, we actually need to define this bean on where this new client factory is actually going to be. So you got to customize the core service context to include this new definition. So after realizing that running this on an indexer and doing search and indexing for 800 users at a given time, the system wasn't robust enough. So we started looking at options that out-of-the-box Solr supports as replication. We have an indexer, we have a search server, running them in 2 different scenarios. You have the ability to now start tuning differently. Challenge is, this is not something that Alfresco supports out of the box. So you have to look at other options like rsync, which involves scripts, cron jobs, poolers. It works well, but it's just a lot of overhead to get that configured. So with a little bit of ear bending, arm twisting, talking nicely to Andy Hind, and just generally making a lot of noise, Andy realized this is actually something pretty easy to support. So he actually added in the support officially 4.18? So officially in 4.18, Alfresco now supports Solr replication using the Java classes. So this is where we now started looking at separate the indexer, separate the searcher. We now have 2 servers, one purely indexing, one purely searching. The wrong button. And again, if you want to go into it now, we have some configuration settings on how you actually set this up. It's fairly straightforward. You're just really telling Alfresco, you go here now to find any of your indexes rather than going over here. The differences now are at the Solr level. So now they refer to this as the master and the slave. So now we got to start configuring our indexer as the master and the search server as the slave. It's fairly easy to do. What we discovered for the slave, we need to disable tracking, although this should be enabled. We think we've got a little kink to work out with so that the slave can still track the Alfresco models. So it will update those to make sure it's aware of what's going on. Some of the things we did was we disabled SSL, but we'll talk a little bit more about that later on. And you actually add 2 more properties to say enable master is false and enable slave is true. So this now lets Solr know we're behaving in a slave mode, we're not tracking, and we're not actually indexing. You also then need to make a little change to the Solr config.xml, and this is per core. So we've got to do this for workspaces and archive and anything else you may include. So if you search down through Solr, you'll see there's an entry in there for the master. And I've actually got these backwards. That's a good start. Just step forward. No, don't have the slave configuration. Okay. Yeah, I'm missing configuration. So if we jump forward to the master, you got to tell the master that you are now going to be doing certain things on replication. And in this case, we've set it up to say every time there's a commit on the indexes, You can replicate. We have enabled that any time there's optimization goes on, you can replicate. And also, you want to make sure you replicate the schemas, the stop words, the default values. And also, we've indicated when you can back up indexes after startup and optimize, but that's something that Alfresco manage on your behalf. From the slave side, you would comment the section out on the master and actually define this as a slave. And it's a couple of properties that you then include to say where you're replicating from. And you simply point it to the master, to the core, and a replication. That's pretty much it. The second property is you need to say how often do you poll the master for your indexes. So in essence, the master is unaware that anybody's replicating from it. And the slave is the one who actually makes the communication. Good practice on the master, just to say, enable that master to be true and tell the slave it's false. It's a master by default, but it just makes your property files that little bit cleaner. So if you really want to get a little bit more complicated and complex, you can now include a repeater in the middle. So if your indexers are overwhelmed by the slaves making requests to get a delta of the indexes to transfer back to them so it can merge them in, you can actually set up a repeater who acts as the middleman. So it's kind of a master-slave, really doesn't do anything for Alfresco except talk to your indexes, get the deltas, make those available for whenever the slaves need to request them. So it takes a little bit of pressure off the indexer. The other option where we're going to eventually, at the minute our Alfresco server is on a separate instance to our Solr server, so they talk to each other over the network. And then one of the next things we will do is collapse Alfresco onto the same indexer. So now we remove the network connection. So we would take a little bit of chatter off the network, improve indexing times, and generally make our users happier and networking happier because we're not bugging them. So this is currently where we're at today, and it gets pretty challenging to take a Visio architecture diagram and put it on a PowerPoint slide. So at the minute we have 3 Alfresco servers which are users access, which are tied to 3 individual Solr search servers. We haven't load balanced Solr yet, but that's the next step that we'll be doing. We have a dedicated Alfresco node which runs all the nightly jobs and interacts with the indexer. So we've taken all the indexing traffic off of the nodes that the users are accessing. And note, everything is on SAN storage. If you can get faster, go faster. And just for your information, this is kind of where we're going. We're going to load balance all our Solr instances. We'll add a second indexer, load balance there, trying to build up more redundancy. We hope to add more to your database to try and add redundancy there. So we really are minimizing failures as best as possible. So at this point, I'm going to pass it over to Corentin, and he's going to tell you a little bit more about how we've ended up in this situation.
So, looking at the facts now, first, one thing which is really important when you consider Solr replication is to have a look at the report from Solr. Here you can tell the frequency of the replication. I mean, you can see the poll interval, which is here about 20 minutes. It means that every 20 minutes the searcher will ask for, will check that if the index needs to be replicated from the indexer. You can tell by the times failed, if the replication failed at some point. You can tell when by looking at the last failure. You can tell by the size of download, the size of the chunk of the index that was last downloaded. So there's lots of really important information. So you always need to have a look at the statistics if you look to improve solar replication. So here are the information you can find in the solar report about the different caches. One thing that is really important is the hit ratio. So here you can see that for this particular cache, the Alfresco reader to ACL ID cache, the hit ratio was very low, about 9%. It means that 9% of the time when solar is using this cache, it doesn't find what it's looking for. And as you can see, there's a lot of eviction as well. So it means that most of the time the entries inside the cache will be evicted and other entry will be inserted eventually. So this cache, as the hit ratio and the eviction, as the hit ratio is very low and the eviction are very important, actually it's better to comment out this cache from the solar config. On the other side, we've got the Alfresco Pass cache. This one has a very good hit ratio, about 97%, with a low eviction rate. So this means that this cache is good like that. We don't need to tune it. We don't need to increase its size or whatever. So as I just said, it's really important to tune solar caches. When you see high eviction, it means that the cache could be too small, so you need to increase its size. You can do that using the solarcore.properties, or you can do it as well in the solarconfig.xml. If a cache has a high evictions and a low hit ratio, often it's worth disable the cache. And something that's really important as well for the replication is the warm-up time. So it means it is a time that will take the cache to be copied to when a new searcher is instantiated inside Solar. So when this time is too important, you should lessen the auto warm count inside the solarcore.properties so that the searcher will not take too much time to be instantiated. I guess we can, if we go back there, you see you've got the warm-up time. So here it's 0 because this particular cache, the Alfresco reader to ACL ID, don't have any warm-up. Actually, that's not a cache that we will copy when a new searcher is instantiated. On the other side, this one takes about 5 seconds for the warm-up, and so the auto warm count value for this cache is not new. Another good practice is to set the size of a cache the size of a cache should be the same as the initial size. This avoids Solar from resizing its cache. That's optimized. That's more optimized. Something you should have a look at as well is to use the appropriate cache for each cache, the appropriate class for each cache. So LRU class is when you have a cache with an important number of inserts. On the other side, the fast LRU is when the cache is mostly readden. So the first thing, so when we consider the replication, you need to tune indexer and searcher different, not the same way. The first thing you need to have a look at is the merge factor. So the higher is the merge factor, actually on the indexer side, it's better to have a higher merge factor. It makes the indexing faster. The thing is that with the replication, merge only happen in the master. So it means that that will never happen on the searcher, and you need to pay attention to that. So the value you will define on at the searcher level will not be taken into account. So if a lower merge factor is good for indexing, on the other side, using a higher lower merge factor is good for indexing, lower merge factor will be good for searching, because we will have less segments to look into. So regarding the replication, another thing is the more segments you will have, the smaller will be the chunk to be downloaded on the searcher. So it's really a balance. You need to check again the Solr report to tell if the merge factor is appropriate. And Miguel will explain as well tomorrow how you can look into the number of segments that are open on the Solr side, and how you could tell what's the best value. So another thing you can tune is the RAM buffer size. So by default it is 32. You can eventually increase it to 64 or 128. This will increase the memory usage on Solr, but it will make the indexing more optimized. So another question you have to ask is, are all the caches necessary on the indexer? I mean, if in Michelin architecture, we don't really use the indexer apart for administrative purpose. It's not exposed. User will not use it to do searches. So it's useless to define important cache, because they will never be used. So it's better maybe to disable all those cache. And why not using that memory to increase the RAM buffer size? Another thing is the cleanup of the temporary ACL. So that could be helpful, but that could help as well on the DB side to lessen the number of rows regarding the ACL, and to help Solr retrieving those ACL. So on the at the searcher level, there is still this merge factor. It won't be taken into account, but it's a best practice to set it the same value that you have in the indexer, because that's the value that obviously will be taken into account. The poll interval, it defines how often the searcher will check the index from the indexer to eventually replicate them if they are not synchronized. So you could, if you are facing issue and if you see that the searcher are if the warm-up time for the caches at the searcher level is really important, you may have to increase the poll interval. Another interesting parameter is the time allowed. That will define the time limit for the execution of the queries. But this is not taken into account for the expansion of wildcard queries. So you have to know that even if you set a time allowed for the queries, you may still observe some long-running queries at the Solr level. It won't totally avoid those long-running queries. Regarding the cache, so there are 3 parameters you can tune: the size, the initial size, and the auto warm count. So the size and the initial size basically should always be the same to avoid Solr from resizing the cache. And the auto warm count should be lessened if you observe that the cache is taking too long to warm up. And this is really important because in some cases you can observe that there is if the pole interval is too low and the auto warm count for a cache is too important, it may happen that some caches will take too long to be instantiated, and you will observe an overlap during the replication, meaning that actually the searcher will try to replicate the cache from the master, and he won't have the time to instantiate a new searcher before another replication occurs. So this is an example of bad tuned replication. So here you can see that Solr was sawtoothing. The consumption of CPU was getting up and down. You can see the memory usage was getting up to 100% or nearly, and getting down to around 50%. In some case, that could be a normal behavior. I mean, if you, with the context of high concurrency we have at Michelin, and the number of queries running inside Solr, you can see some sawtoothing. It's normal. I mean, if Solr is executing some wildcard queries, for instance, that could happen, but that shouldn't stay for a long time, as we can see here. So here, basically, what was happening is that there was an overlapping between the searcher was trying to replicate content, and he didn't to replicate indexes, from the master, but he didn't get the time to instantiate a new searcher before another replication was occurring. And at the same time, lots of users were executing queries inside Solr.
What essentially happens at this point, your Alfresco node becomes unusable. And that puts you in a bad situation, and you may also be faced where that node now maxes out its database connections, but the users are still hitting it because your load balancer still has it enabled. So you end up in a pretty bad situation when you end up with the sawtoothing effect that we experienced. Now, working with Alfresco and Alfresco engineering, they realized there were a few issues, particularly around the wildcard expansions. So it is important to talk with your TAMs and keep up with the patch levels, because they are fixing things for you.
So here is what we observed after we upgraded Alfresco and tuned the caches. So basically we decreased or we increased the poll interval so that the replication now occurs every 20 seconds, whereas it was happening every
Well, yeah, the replication at the minute
sorry,
every
20 minutes. Not
Previously
20.
it was every 2 minutes, and that's where we had the problems. So if you need basically your documents to be available real time, obviously a 20-minute polling period is a little too long. The plus of this, the replication has reduced from, say, 15 minutes down to a couple of minutes, and it's every 20 minutes is when the replication is actually taking place, so that has improved greatly. But it also means we can now look to narrow that pole interval. So if 20 minutes is too big and everything's being accomplished within 2 minutes, we'll probably reduce that down to a 10-minute window. Again, assess the caches, monitor everything. As long as we're keeping this nice level effect, then we can even look to reduce the pole interval further.
So here are some other interesting stuff you can tune regarding solar. So basically using SSD is helping a lot on the solar side. You can even allow to reduce, often using the usage of SSD allows you to reduce the memory required by Solar to execute the queries. Something that everybody should do actually is to disable the full text indexing on the archive space store, because it's not really used by default. You should always monitor closely the GVM and of both Solar and Alfresco. You have to take them both into account, because the transformation that occurs on the Alfresco side should be considered at the same time that the indexing on the Solar side. So yes, something really important as well when you face issues on the indexer is to tune the transformations on the repository side, because sometimes you don't understand really why there's an issue at this on the indexer, and actually it's because of some transformations that are not optimized within Alfresco. The SSL should not be enabled unless you really need it, because it created an overhead, as Colin said before. And you should always, at the Solar level, you shouldn't allocate all the memory from the server to the GVM. It's really important to save some memory for the disk cache. Otherwise, Solar will not be. He couldn't access he couldn't read the disk, the segment on the disk, and this won't be optimized. And yes, we've got at support, and I think it's on Alfresco documentation as well. There's a sizing spreadsheet you can use for setting the XMS value depending on the number of ACL, the number of node and transaction you've got inside Alfresco, sorry. A side effect of the replication now is the consistency. That's really important to mention, because obviously replication helps a lot with high concurrency, but on the other side, the consistency of searches is impacted. On Solar, on Michelin environment, for instance, indexes are replicated every 20 minutes right now, so it means that it can take up to 20 minutes for a user to access a content that has been uploaded or a change inside a content. Another side effect is the network impact. So obviously the replication of the Lucene segment of the index segment is using the network, and this can be you should monitor that. It's really important.
So I think really we're buffering up on time here. We still got a little bit more, but if anybody's any questions at this point, we're happy. Sorry, some just behind you, Miguel.
No. Besides using the spreadsheet that was mentioned in one of the slides, is there a better way to figure out how much heat on space need to be allocated to the stable?
To be honest, it's a good question. The calculations from the solar sizing spreadsheet would indicate our JVMs should run comfortably with 8 gigs of memory. Ours do not run in that space. After we've done the tuning and resizing, they really sit nicely around the 14 gig and maybe peak around the 20 gig. So we really haven't found a foolproof way to figure out what's missing on the sizing charts, the spreadsheets, to figure out, 8 gig to 16 gig, there's something missing there. I don't know if Miguel or Carrington have come across anything, but there's something missing. We haven't figured that out.
We ended up spending almost a week looking at Visual VM, and then, because whatever the numbers that the spreadsheet gave us, was around 20 gig, and we finally ended up using 30 gig about 4 or 5 days to figure out what's the gig.
What version of Alfresco are you using?
No, this is Direct Solar.
Okay. Then we're not worried about that.
You talked about replicating the indexes, but what is the actual process? Are we doing like a delta replication of what the slave has compared to the master, or do we download the indexes, everything? What indexes? What happens in the
If you decipher the documentation, it implies that it would be a segment would be replicated, but when you see the replication handler, in theory it should be a delta. It should be what has changed since I've last asked you, and that's what should come across. When we did the snapshots of those images before, the delta was 96 megs. So that would imply it's not bringing across a 100 gig segment each time.
And it depends if the replication is performed after a commit or after an optimize. Because if it is performed for a commit, we should replicate only the chunk, only the segment in which the commit happened. If it was an optimize, then we should send all the indexes.
Okay, that makes sense.
So the sizing guidelines that you have, right, that only gives you a point in time now, it doesn't give you forecasts for a year from now, right? So there's always a chance that you're going to size it for today, 6 months from now, you're going to run out, right?
Yeah.
There's no projections, there's no calculations.
So the numbers that are in that spreadsheet, you can adjust them based on the projected growth.
Yeah, it hasn't been,
Well, I mean, you can just put, like, say,
Right.
if we have 10,000 nodes, we're going to project 20% growth over 5 years, so just put in the bigger number.
So we've actually a modified version of that spreadsheet for that purpose, and also adding in for the version 2 store. If we were to include that, although it's not supported, but it actually does work pretty well. If we include that version 2, then we can include those values and say, if we're going to be doing a 10% growth each month to try and predict what it's going to be.
Couple questions on this. Do you recommend RAID for solar disk?
We recommend flash storage.
Rate 10 is fine, but not 5 for sure.
The other question on flash though, flash solid state disk, are you going to burn it up quickly by rewriting a whole lot of stuff?
Yeah, I mean,
It's limited, right?
it's not as bad as what it used to be. They've improved a lot. There are white papers available now in cost analysis on flash storage versus your typical spindle storage. And a lot of people are now coming to the conclusion that the extra bit of cost is worth it if you want, reliability and speed of applications for your users. Some people are not prepared to take the cost on.
Okay, thanks.
Do you have any guidance on, like, if I'm sizing a system, I can look at that spreadsheet and it'll tell me how much RAM to allocate. But if I know, okay, I need to be sizing for 10 concurrent queries or 50 concurrent queries, do you have any sense of how to predict how many concurrent queries? Obviously, every query is different. But sort of a best effort how to predict how many concurrent queries one solar instance can handle?
We haven't got to that extent, but now that you mention that, there's a talk tomorrow, Lewis, on how to size your systems, and he's going to be getting into the weeds on database and solar sizing and touching on areas like that. I know that's what I'm going to go to tomorrow. But certainly what we've noticed from 4.14 to 4.18 There's been a number of great bug fixes which has reduced the memory usage of Solar, because they've rewritten some of how they parse the queries and how they send them over to Solar, and that's made a big, big difference.
Especially regarding the wildcard queries.
Oh yeah, the wildcard queries are bad.
Yeah, they were all.
Now they're not as bad.
Is there a link to that size expression on a personal website or is that on the support website?
I thought it was on Docs. That
It is in
also-
that first documentation.
Yeah.
Yeah. Anybody else, sort of, you want to get out of here? Oh, thank you very much for joining us.